Hello everybody, today I wanted to make a video talking about the essential components you're going to need to build your own computer at home. So, to get you started, there are 7 things you are going to need, unless you want to get into video gaming or video editing or streaming, anything like that. Then there is a 7th component. So the main 6 you are going to need is your CPU, your RAM, your motherboard, storage, power supply, and a case. I'm going to go into a little bit more depth on each of these, and then we'll talk about what you're going to need for gaming in just a minute. So first of all, we have our CPU. The CPU is kind of like the brain of the computer. It's what does all your software processing. There's so many options for this. You can go with new stuff, and honestly, with the newer stuff, it doesn't really matter what choice you make. It all comes down to the needs that you have and that need to be fulfilled by your computer. But for just basic web browsing and basic app use, you can get away with basically anything modern. Now, if you're going used, there's tons of options out there, but there is a certain cutoff point for the age of the CPU and motherboard platform that you're going to want to cut yourself off at. And for that, I would say for Intel is around the 6th generation or the 6000 series core processors. And for AMD, you're going to want to look for anything newer than the 1st gen Ryzen CPUs. This is just to avoid any problems that come with having a CPU that is so old that it can't do modern things. Now, to support your CPU, you're going to need a good enough motherboard. And when I say good enough motherboard, it's not so much that there's bad options out there. It's that you're going to need a motherboard that is suitable to the system that you're speccing out. There's tons of options, and each manufacturer, whether it be, MSI, it doesn't matter. Whoever makes the motherboard, that's not what matters. What matters most is the chipset of the motherboard, because that's going to define the compatibility with your CPU and other features. So this is something you're going to want to do some individual research on, is how to choose a motherboard. Basically, your motherboard ties all the components in the computer together and makes everything work seamlessly. So, yeah, tons of options out there. Actually, in my personal computer, I use a very cheap Chinese brand motherboard, and I'm not really worried about it at all. So, that is an option if you're trying to save a buck or two. So the next component we're going to look at is RAM, and RAM has 2 main specifications that you're going to want to look at. The first is capacity, so that'll be your 4 gigabyte, 8 gigabyte, 16 gigabyte, up to 64 or even 128 gigabytes for desktop platforms. And the sweet spot here in 2025 is 16 gigabytes of RAM. You can get away with 8 gigabytes. However, you will be pretty limited if you want to do more like hardware intensive work on your computer. So keep that in mind. You can get away with 8 gigs. However, I personally would recommend that you go with 16. It'll give you some more longevity out of the computer. You'll have more capabilities down the road if you find yourself getting into video games or whatever it may be. Now, the second specification you're going to be looking at is the speed that is usually specified in mega transfers per second, which is basically how many bits of data your RAM can transfer to the CPU every second. Now, with older platforms, the standard was around 1600 megatransfers per second, or back in those days, they used to say megahertz. Nowadays, with DDR5 platforms, we're looking at speeds of up to 6,000 and even higher mega transfers per second. And this is one of those things where you're only going to get the higher speed stuff if you really value having a fast computer. I mean, your entry level stuff, especially for like RAM and storage, there really is no bad option. And even if you want to do more intensive games, that lower spec stuff can save you some money and won't have super drastic effects on performance. Now, the next component we're going to look at is storage. Nowadays, we've leaned away from hard drives and we've moved to SSDs or solid state drives. And the main difference is speed and response times. SSDs are much, much faster. However, the benefit to a hard drive is you can get far more capacity for less money. So some people have hybrid systems where they'll run an SSD to run their operating system, and then they'll have a hard drive to store larger files like video files, photos, whatever it may be. They'll store that on a hard drive. Now, if you plan on installing a bunch of video games, I would recommend that you lean away from hard drives, seeing as new games do actually rely quite a bit on the speed of your storage to perform properly. And you'll see that in the recommended specs of most games is that a lot of them recommend an SSD, and I have the same recommendation. Now, when it comes to SSDs, there's three main formats you'll see. You'll see the 2.5-inch SATA SSD. And these things are great because they're inexpensive. You can get decent amount of storage at a decent speed for a decent price. It's a very good middle ground. It's a little dated at this point, and everyone's moving towards the M.2 SSDs. Basically, what an M.2 SSD is it's a SSD that slots into your motherboard. Now, there's two types of M.2 SSDs. There's SATA and NVMe. Now, the difference here is that the SATA SSDs run off of the storage controller of your motherboard, which then gets sent to the CPU, which, you know, there's that middleman there. It relies on your motherboard. Now, with an NVMe SSD, your SSD is connected through what's called the PCI Express bus, and that goes directly to your CPU. So it's a much shorter path for that data to travel to your processor. So NVMe SSDs are kind of like the bleeding edge. That's where you get your highest speeds. However, you also see your highest prices with NVMe SSDs. So keep that in mind. Don't be afraid of SATA SSDs. They're not the worst thing in the world, and they can save you lots of money. Now, of course, you're going to need something to power all of these components, and that's where we look at our power supply. This one's pretty straightforward. There's two things you're going to want to look at, and that is your wattage rating and your efficiency rating. Now, unfortunately, there's no standardized rating system for actual quality. That's going to be brand to brand, and so I recommend that you look at reviews and do your research on specific power supplies before buying. Now we're going to look at the wattage rating, and this one's pretty straightforward. There's tons of online calculators where you're going to punch in all the individual components in your computer, and it's going to spit out a number, a ballpark number of watts that your system is going to consume, or that it can consume, and then you're going to want to spec your power supply wattage according to that number. And this is one of those things where you can go overkill and it will actually put a lot less strain on your power supply. However, you will be spending a little more money if you do it that way. Now, the next thing to consider when it comes to power supplies is the efficiency rating. This is as close as we get to standardized quality control across power supplies. This is where you're going to see the 80 plus bronze, silver, gold, I think platinum and titanium ratings. Basically, in that order, it goes up in terms of efficiency. And that's basically how much power comes from the wall actually gets to your components. The lower the efficiency rating, the less efficient your power supply is. And so you're looking to get an efficient power supply, and that will actually put less wear and tear on your power supply as well, is having a well-rated power supply in terms of efficiency. And now power supplies come in a few form factors. You have your SFX and your ATX power supplies. SFX is going to be a little more expensive, and these power supplies are actually very small, and they're designed to go in very small cases, which is why they're usually more expensive, is because they have to be so compact. Now, your standard case is going to be an ATX form factor, and this is what the majority of your power supply options are, is ATX. That is a standard form factor for computer parts. That's actually something to note. That applies also to motherboards. You'll see all different size motherboards. There's mini ATX, micro ATX, full ATX, eATX, and then you have your ITX motherboards, which is again for very small form factors. I forgot to mention that earlier, so I apologize for that. Now, we've covered all the basic components that you're going to need to get started. And from here, this is where you add a little bit of personalization to your computer. And this is the actual enclosure. So this is going to basically depict what your computer looks like. This also falls into the form factor thing of your ITX, mini ATX, micro ATX, full ATX, eATX. These are all different form factors and will like depict the size of your actual case and your computer as a whole. Now, when it comes to ATX cases, there's full ATX and I think it's mid-size, mid ATX, something like that. And that's kind of the standard, is your mid tower. That'll fit most motherboards, most graphics cards, most power supplies. But again, this is something to do research on if you're considering doing a more small form factor computer, or you're just looking for general compatibility. Is you're going to want to look into those labels: ATX, ITX, SFX, not SFX. SFX, I'm pretty sure. And then, of course, your mid tower and your full tower case sizes. These are all things to consider when you're choosing your components. Now, another thing that affects the look of your PC in a lot of cases is the actual cooling fans. So this is things like you have your RGB fans, which are going to be, you can change the colors of them. And then you have your standard LED fans, which are a single fixed color. You have simple black fans. You have noise reducing fans, which makes your computer quieter. And actually, on the topic of fans, that reminds me that a very, very crucial component to building a computer is your CPU cooler. This is something that you don't want to be afraid to overspec, but again, form factor is always something to consider. So look into your case specifications to see how much room you have for your CPU cooler, and then check the CPU cooler you want for compatibility with your motherboard as well as your case. This is specifically important for tower style coolers. And if you're doing a small form factor, there are low profile coolers you can look into. So again, do more research. This is just a video to get you guys the basics, the basic knowledge of what you're going to need. Okay. So once you have all those components chosen out, you're basically ready to go. And as long as you check your compatibility between parts, then you're ready to choose your operating system and get your computer off the ground. That is, provided your CPU has integrated graphics and you can run off just that. Now, if you have the extra budget and you're looking to do things like playing video games, editing videos, live streaming, things like that, you may, well, you should consider a graphics card. Now, graphics cards, there's so much out there, so I would recommend watching an entire other video, and actually at some point I might make a full video talking about graphics cards. Now, again, form factor is everything. There are tons of different sized graphics cards. There are low profile graphics cards. There's basically a graphics card for any use case that should have enough horsepower to get you through what you're doing. So yeah, do your own research on these individual components if you want to know more. And if you think you found something that appeals to you, whether it be your price range or the features that you want, definitely look at reviews. So that's basically gonna wrap up this video. I just wanted to make a quick video talking about all the basic computer parts that you're gonna need to build your own computer at home. So I want to thank you guys so much for watching. If you have any feedback, if you have any comments, leave them down in the comment section. I don't do this often, but I ask maybe that you guys subscribe if you want to see more content like this, and be sure to ring the notification bell so that I know that you guys are enjoying my content. Yeah, that's it. Thanks.